Hello friends, this lesson is all about second law of thermodynamics. Previously we have discussed the first law of thermodynamics. We have discussed the various processes, both closed system as well as open system we have discussed. We have discussed the constant pressure, constant volume, isothermal, adiabatic, polytropic process, work transfer in all those processes, heat transfer in all those processes, first law of thermodynamic equation for closed system open system, but this lesson is all about second law of thermodynamics. Please go through the previous lesson so that you can understand this letter much better. But before proceeding further, I would like to introduce myself. My name is Harshit Agarwal. This is all about me. I have cleared the Indian Engineering Service Examination, GATE examination, got the offer letter from most of the Maharatna and Navratna companies. You can always rate, review, recommend and share this course. You can also follow me on the specified link. So to start with, what is the second law of thermodynamics? See, according to second law of thermodynamics, complete conversion of low grade energy into high grade energy is impossible in a cycle. See, as I have already told you, heat is a low grade form of energy. Heat is a disorganized form of energy, whereas work is a organized form of energy. Work is considered as a high grade energy. So you can completely convert the high grade energy into low grade energy, but low grade energy cannot be completely converted into high grade energy. There has to be some form of heat rejection, right? So work can be completely converted into heat, but heat cannot be completely converted into work. So work can be completely converted into heat, but the complete conversion of heat into work is not possible. So heat and work are not completely interchangeable forms of energy. Some heat has to be rejected. And as I have already told you, work is said to be a high grade energy and heat is a low grade energy. So complete conversion of high grade energy into low grade energy is possible, but the complete conversion of low grade energy into high grade energy is impossible. So what is cyclic heat engine? A cyclic heat engine is a thermodynamic cycle in which there is a net heat transfer to the system and net work transfer from the system. See, this is the cyclic heat engine. Heat input, heat rejection, so there is a net heat input which is Q1 minus Q2, work output minus work input, so there is a net work transfer, that is WT minus WP. So the system which executes a heat engine cycle is called a heat engine. Net heat is equal to Q1 minus Q2, net work is equal to WT minus WP. So from first law, in a thermodynamic cycle, we know that the net heat transfer is equal to net work transfer. Sigma Q is equal to sigma W. Q1 minus Q2 is equal to WT minus WP. If you want to calculate the efficiency of a thermodynamic cycle, we have to find net work output upon heat input, total heat input. As you have already know, efficiency is always net work output upon heat input. So net work output, what is the net work output? Net work output would be WT minus WP, work done by the turbine minus work done on the pump, divided by total heat input. So WT minus WP upon Q1. But from फर्स्ट लॉ से हमें पता है Q1 माइनस Q2 इज इक्वल टू WT माइनस WP. सो WT माइनस WP की जगह हम लोग लिख सकते हैं Q1 माइनस Q2 अपॉन Q1. सो द एफिशिएंसी ऑफ ए साइक्लिक हीट इंजन इज इक्वल टू 1 minus Q2 by Q1. Now, this is a very important term for thermal energy reservoir. Please understand the concept of thermal energy reservoir in detail, because while calculating the entropy, I am moving towards the entropy. Be focused, be concentrated. I am moving towards the entropy. तो thermal energy reservoir का concept वहाँ पे बहुत useful होगा. So what is the source? A thermal energy reservoir is called a source if it can reject large amount of heat without undergoing any large amount of thermal energy or heat without undergoing any temperature change. And sink is a thermal energy reservoir which can absorb large amount of thermal energy without undergoing any temperature change. See, there are two thermal energy reservoir. One is source and sink. For example, sun, SUN, is a thermal energy reservoir and it is giving you so much of heat, but its temperature is not changing. And atmospheric air is sink. You are rejecting so much of heat to the atmosphere, but its temperature is not changing. So thermal energy reservoir is something of which its temperature does not change. There are two thermal energy reservoirs, source and sink. You are taking heat from the source, its temperature is not changing. You are giving heat to the sink, its temperature is not changing. Fine. Next, very important, Kelvin-Planck statement of second law. It states that it is impossible to construct a device which working on a cycle which produce work other than work with a single reservoir. See, this is a thermodynamic cycle. If you have to take net work out of this heat engine, heat QH at higher temperature TH is inputting to the heat engine, and heat QL to the lower temperature is rejecting. So net work is equal to QH minus QL, right? Network is equal to QH minus QL. So if you want to calculate the efficiency is equal to net work done upon heat supplied, which is equal to 1 minus Q2 by Q1. So Kelvin-Planck statement of second law states that if you have to get the net work output of from a heat engine, you have to run that heat engine between the two thermal energy reservoir, one at higher temperature and other at lower temperature. So no heat engine can be 100% efficiency. There is no heat engine which can be 100% efficient, because there has to be some heat rejected, because we know that the efficiency of formula of efficiency is 1 minus Q2 by Q1. So if Q2 is equal to 0, then there is no meaning of this reservoir. अगर Q2 की वैल्यू 0 हो जाती है तो इस रिजर्वायर का कोई मतलब नहीं है. तो इस रिजर्वायर का अगर कोई मतलब नहीं है तो एफिशिएंसी क्या होगा? 100% होगा. So no heat engine can 100% be efficient. The heat engine are based on Kelvin-Planck statement of second law. Simply, if you have to take the net work output, you have to run heat engine between two reservoir. So if Q2 is equal to 0, heat engine will produce net work in a complete cycle. Heat engine will produce net work in a complete cycle by exchanging heat with only one reservoir, thus violating the Kelvin-Planck statement. Such a heat engine is called perpetual motion machine of second kind. Previously, I have told you the perpetual motion of machine of first kind. If you have to get the work, you have to supply heat. Perpetual motion of second kind says if you have to get the network, you have to supply. There should be two thermal energy reservoir, two bodies at different temperature. Then only you will get the work W. Just keep in mind the statement of second law of thermodynamics for objective point of view. Next, Clausius statement. Clausius says it is impossible to develop a cyclic device which transfer heat from a lower temperature to a higher temperature without any external energy input. It says if you have to transfer heat, this is the concept of refrigerator and heat pump. If you have to transfer heat from a lower temperature to a higher temperature, you have to supply some external energy, some external work. If you will not supply that, see the formula of CPU is Q upon W. If you will not supply W, COP is infinity. There is no such device whose COP could be infinite. सो अगर आपको लोअर टेम्परेचर से हायर टेम्परेचर पे हीट पहुंचाना है, अगर आपको लोअर टेम्परेचर से हायर टेम्परेचर पे हीट पहुंचाना है, तो आपको कुछ एक्सटर्नल वर्क करना पड़ेगा, फॉर एग्जांपल रेफ्रिजरेटर व्हाट रेफ्रिजरेटर इज डूइंग, रेफ्रिजरेटर इज रिजेक्टिंग हीट टू द एटमॉस्फेरिक एयर, कूलिंग द इनसाइड बॉडी with the help of work W, which is consumption work, and there is a compressor inside the refrigerator which is consuming that work. So this is the complete process of refrigerator. We will discuss this. What is refrigerator? A refrigerator is a device which operating in a cycle maintains a body at a temperature lower than the temperature of surroundings. Just like efficiency in a heat engine cycle, see, for in a heat engine cycle we have to calculate the efficiency. Just like efficiency in a heat engine cycle, there is a performance parameter in a refrigerator cycle called coefficient of performance. There is a two coefficient of performance. One is the coefficient of performance for refrigerator, एक refrigerator के लिए coefficient of performance है, and the other one is the coefficient of performance for heat pump. See, what is the coefficient of performance? Coefficient of performance is equal to desired effect upon work input. Coefficient of performance is equal to desired effect upon work input. See, the main purpose of refrigerator is to do cooling. This is the lower temperature. So this is the desired. We have to extract heat from this thermal energy reservoir and give it at higher temperature. So desired effect is QL and work input is equal to W. So COP is equal to desired effect, which is QL, and work input is W. QL upon W. And W is QH minus QL. So COP of refrigerator is equal to QL upon QH minus QL, because हम W को higher heat minus lower heat लिख सकते हैं. I am again repeating, if you have to calculate the COP of refrigerator, desired effect upon network input, Desired effect is QL, net work input is QH minus QL. Similarly, for heat pump, a heat pump is a device which operating in a cycle maintains a body at a temperature higher than the temperature of surrounding. So if you have to calculate the COP of heat pump, it is desired effect upon work input. Desired effect for heat pump is equal to QH upon W. So QH is in a numerator and W is QH minus QL. Fine. For refrigerator, it is QL, lower temperature, lower heat upon W. For the heat pump, it is higher heat upon W. Just keep in mind this particular formula: COP of heat pump is equal to COP of refrigerator plus 1, and QH is equal to COP of heat pump into W. Always keep in mind QH is always greater than W. Heat rejected to the heat, higher temperature is always greater than W. Heat pump provides a thermodynamic advantage over direct heating. If there is a room heater, the amount of heat you will be getting from room heater is less than the amount of heat if you will add a heat pump. If you will add a heat pump to a room, so heat pump is a more beneficial than a room heater or direct heating. Fine. Now this is the Carnot cycle. Carnot cycle is very, very important. Four important processes of Carnot cycle is 1 to 2 is reversible adiabatic compression, 2 to 3 is reversible isothermal heat addition, 3 to 4 is reversible adiabatic expansion, and 4 to 1 is reversible isothermal heat rejection. These are the important principle of Carnot cycle. The efficiency of a irreversible heat engine cannot exceed the efficiency of a reversible engine between the same two reservoirs. If there are two reservoirs, between them there are two engines, one is reversible and other is irreversible. Efficiency of reversible engine is always more than the efficiency of irreversible engine. Keep this in mind: efficiency of reversible is always higher than the efficiency of irreversible. Second statement: the efficiency of all reversible heat engine operating between the same reservoirs are same. I mean, if the efficiencies of all reversible engines between the same temperature limit T1 and T2 are always same. Now, perpetual motion machine of third kind, a device which runs continuously without absorbing energy from the surroundings in any form, neither work nor heat, and also does not develop any work. It is possible only in the absence of friction, hence it is practically impossible. This is the statement of perpetual motion machine of third kind. Keep in mind the statements of PMM1, PMM2, PMM3. PMM1 says if you have to gain work, you have to supply heat. PMM2 says if you have to gain work, net heat engine from a cycle, you have to run the cycle between two different reservoirs, and this is the statement of PMM3. Just keep in mind these three statements. These are very, very important. Next, what is the third law of thermodynamics? See, I am telling you again and again, from first law you got the concept of internal energy. From second law you got the concept of entropy. We will see that what is the main concept of entropy. Entropy is very, very interesting, very, very logical. You will gain lot many of concepts for examination point of view in my entropy lessons. This is the third law of thermodynamics. It says it is impossible to reduce a substance to absolute 0 Kelvin, no matter how idealized procedure it is. See, it is very difficult. It is very, very difficult to reduce a substance to a temperature of 0 Kelvin. This is the third law of thermodynamics. The entropy of a pure crystalline substance is 0. See, the entropy of a pure crystallized substance is 0 at 0 Kelvin. 0 Kelvin पे एंट्रोपी की वैल्यू 0 हो जाती है, लेकिन किसी भी सब्सटेंस को 0 केल्विन पे पहुंचाना बहुत ही ज़्यादा डिफिकल्ट है. दिस इज सिंपल थर्ड लॉ ऑफ थर्मोडायनेमिक स्टेटमेंट. Thanks a lot from my side. If you have any doubt in this lesson, you can ask me that. Thank you all.